Lesson 8, lesson practice. Let's take a look at letter A. A mourning dove, put your hands like this. A mourning dove can reach speeds up to 35 miles per hour. How fast is this in feet per hour? When we're doing our unit analysis of length, we have to come up with what would be that conversion rate or that unit that you're going to use to change. In this case, it's asking us to change from what would be miles into feet. Here's my initial measurement of miles per hour. I need to change that into feet per hour. Because I'm only changing the miles portion of the length and not the actual time in the rate, I only need one part of this to be converted. So I'm thinking to myself, what's that unit conversion? 1 mile is how many feet? 1 mile equals 5,280 feet. Now the way in which we write that as a unit analysis is as a fraction in which they're actually equal to each other, those two distances. 1 mile over 5,280 feet is actually the same distance, so it's written as a fraction here, or if you flip that, the reciprocal can be written as 5,280 feet is equal to 1 mile. Now we're going to use one of these in our conversion by setting it up in this way. 35 miles per hour is going to be multiplied by what conversion rate to change it into feet per hour? Now I should write feet here because we want to cancel out miles. If miles is in the numerator for our very first measurement or our very first rate, we want to get rid of miles, so we need to put it in a position where it would cancel. We know that when we're multiplying fractions, you can cancel when they are one in the numerator, one in the denominator. So I need to make sure that miles is down here. Well, which one of those two rates has miles in the denominator? Boom, this one. So I would fill in 5,280 feet in 1 mile. Now I have my conversion rate to get it into feet per hour. Here's how that would work. Miles, because they're the same terms, would cancel. None of the numbers can cancel in this case because they don't have any like terms or factors between them. So I simply multiply numerator times numerator and denominator times denominator. Here it's going to take maybe a helpful calculator or some long multiplication to say what is 35 times 5,280. Now if I just think off the top of my head, it's 184,800. If you don't believe me, check on your calculator. That's just how it's done. Boom. Lesson 8, practice problem B, refers to example 2 in which you're using your unit analysis to convert area. Now when we learned about area and volume, we learned that you're taking what you have as a conversion not only one time, but twice in terms of area and 3 times in terms of volume, because there are 2 dimensions or 3 dimensions in those different types of measurement. Here in letter B, it says an interior wall. Look at this nice little interior wall. I even have the couch and the coffee table and a little lamp where that interior room is. Measures 4.5 yards by 3.25 yards. What is the size of the wall in square feet? So here, area is in yards squared. So we're going from yards squared to feet squared. To do that, we're going to need the conversion to be done twice so that you convert yards to feet, not only once but twice. Your conversions would then be, well, 1 yard is equal to 3 feet, written as a fraction, or for a unit analysis, you would say 1 yard over 3 feet, or 3 feet over 1 yard. And you're going to find out which one of those is the best optimal way in which you're going to multiply by what this value gives us. However, the problem doesn't start out real simple because it's going to actually give you the area. To find the area, you're going to have to multiply that length times that width. Let's do that first. You've got 3.25 times 4.5, because it's multiplication, I don't need my decimals to line up, but I will need to remember how many places I have at the end. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12, carry the 1. 5 times 3 is 15, plus 1 is 16. Add a 0, move over to our second place value. 4 times 5 is 20. Add the 0, carry the 2. It's already there. I'm going to use that again. 4 times 2 is 8, plus 2 is 10. Add the 0, carry the 1. I'll use that one again. 4 times 3 is 12, plus 1 is 13. Add those up. You've got 5, you've got 2, you've got 6, 1 and 4, 4, and 1. Now that looks like a really big number. However, with our decimals, you got 1, 2, 3 places, so 1, 2, 3 moves. You got 14.625 yards cubed as your area. Now your very first option is to take that value and convert it into feet squared by doing two types of multiplication. Now let's remember 14.625, and if we're in yards, we're going to need to multiply by something that's going to cancel yards. So we're going to use this conversion rate because yards is in the denominator, here yards is in the numerator. Let's set that up so you can see what that looks like. We've got 14.625 yards squared. I'm going to write it like this. Yards times yards, because that's yards squared. You're going to then convert that using your unit analysis, saying that that's multiplied, well, 3 feet is 1 yard, and 3 feet is 1 yard to cancel. Now, this yards cancels with this yards cancels with this yards, and my answer then is going to be written in feet squared, because feet times feet would be feet squared. What's 14.625 times 3 times 3, which is 9. If I'm going to double check, that looks like it's 131.625. If we use your calculator to do that type of calculation, instead of having to write that out and do two different types of multiplication. 131.625. We're done. That's using area and double converting that because you've got twice the 2 dimensions for that calculation. Now, could you do it a different way? Instead of having to remember to do both of those, you could. The way in which you would do that is to convert this one to feet first and this one to feet second and find that same answer. Well, if you tried that, guess what? You'd be doing the same thing in terms of that conversion 2 different times. Well, let's try it and see what that looks like. 3.25 yards is our distance. If I do it in terms of length, I would then multiply that by my same conversion. 3 feet over 1 yard, yards would cancel, 3.25 times 3. The second one that I would do is 4.5 times 3 feet over 1 yard, and I would get my 2 values. Now to find the area of that, I'll find those 2 values, and then I will multiply those together to find area, because it's length times width. So 3.25 times 3, 3.25 times 3 equals 9.75 feet. That's how tall the ceiling is, 10-foot ceiling close to. Here you have 4.5 times 3, and your room is 13.5 feet. Now let's see if we multiply these 2 together, get the exact same answer here, because technically we're doing the same sequence or same mathematical problems, just in a different order. You've got 9.75 as your height times the length times width, or height times width in this case, times 13.5 equals 131.625. Because that's feet times feet, you're going to mark that as feet squared. I got both of my answers. This is the way in which your book teaches you to do it, as in do both of those conversions at the same time after calculating what would be that single unit of area. You can also break it into those individual measurements, but you guess what? Doing the conversion not once, but twice, just like you're supposed to with area. If it's volume, you do it 3 times. Lesson 8, letter C, with more of Mr. Shane's famous illustrations. Letter C says, Della has a small bag containing 50 cubic centimeters of potting soil. Her planter, the pot, has a volume of 46,300 cubic millimeters. Does Della have enough soil to fill the planter? Explain. Does she have enough to fill it up so that she can plant what she wants to plant inside of it? That illustration shows here the different volumes that those objects have. In example 3, you're talking about volume. Volume has 3 sets of dimensions, and because those 3 dimensions all need to be converted using unit analysis, you need to do 3 of those unit conversions. We're going to try and change from centimeters to millimeters. To do that, we need to take a look at what that conversion is. 1 centimeter equals 10 millimeters. 2 ways in which you could write that as your unit conversion is 1 over 10 millimeters or 10 millimeters over 1. We'll decide which one of those is going to be best for us based on which of these 2 values we want to convert. Now, because the question says, does her planter have enough volume, why don't we start with the planter itself and then convert it to see if it is greater than or less than this actual value. So if I start with 46,300 millimeters, and now I set up my conversion to change millimeters to centimeters, it would look like this. Let's pick the right one. Millimeters here is in the numerator, There are 3 of them, so I need to write 3 of those conversions, and I need to have millimeters in the denominator. So the best one for me is going to be here. I got 1 over 10, 1 over 10, 1 over 10. If I write in my correct labels with each of those, that would remind me to cancel, 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 and I'm left with centimeters, centimeters, centimeters. So my answer is going to be in terms of centimeters cubed, and then we can compare those 2 values for our final conversion. Now, if you would do the multiplication here, you would recognize that we multiply numerators and then we would multiply denominators. Well, in this case, you've got 46,300 times 1 times 1 times 1, which is itself 46,300. In the denominator, you've got a different scenario in which you've got 10 times 10 times 10. Power of 10 would be 1,000. Now, anytime you have that power of 10 being used in our unit analysis, you're basically just going to, in this case, divide and then move the decimal place based on that division. There are 3 zeros in this 1,000 in our denominator, which means that our decimal point here technically just moves 3 places to the left. Let's do that calculation. 1, 2, 3. And our new answer is going to give me 46.3 centimeters cubed. The question says, does she have enough to fill her planter? The answer would be yes. She's got 50 centimeters cubed. The pot can only hold 46.3 centimeters cubed or cubic centimeters. Therefore, she's got more than enough. Letter D in your example problem refers to what was done in example 4, how to convert currency. Again, you're using a unit of measure to do the unit analysis and equate those units, and then by multiplying, converting those units. Arthur just returned from London. He has 16 British pounds to convert to 2 American dollars. If the exchange rate is 1 pound equals $2.16, $2 and 0.016 cents, what is the value of Arthur's 16 pounds in dollars? So if you look at the solution to the example problem here, you have what would be your conversion. First, you have 16 pounds, and you need to get that into dollars. Then it says equate the units and write it as a unit ratio. Here's your unit ratio. 1 pound equals $2 and 0.016 cents. So you write it as a multiplication sentence in which this would be 16 pounds times 2.016 over 1 pound. That way the pounds would cancel. When you would multiply 16 times 2.016, you'd get 32.26.